This is going to be the second section of Chapter 8, which is actually the first section because we kind of skip over 8.1 for now. This is going to basically be a review on right triangles and stuff, so we're going to be going over the Pythagorean theorem, how to apply it in different situations, and then maybe a little new twist on it at the end. So it should be kind of a review-ish video. But let's go ahead and look at some stuff here. So remember, the Pythagorean theorem applies to only right triangles, and it basically says that the sum of the squares of the two legs is equal to the square of the hypotenuse. So that means that we usually represent it as a squared plus b squared equals c squared. So we have a right triangle here, right angle, and then usually they'll say this side is maybe A, this side is B, and then this side here is C. The side across the right angle is always the C side. And then this is the formula that results from the fact of this being a right triangle, that if you take this number squared, add it to this number squared, you get this number squared, and that's usually called the Pythagorean theorem. So some definitions here once again. Hypotenuse is always the side that's opposite or sometimes set across the right angle, and it's always the longest side. So if you're unsure which one is C, whatever number is biggest, that's the side that's going to be C. So normally if you have a right triangle, the way you can identify C is you take your pen and your pencil, you put it on the right angle, and you draw an arrow straight across, and that arrow points to your hypotenuse. So this would be your HYP, this would be your hypotenuse, or again, usually called C in the problem. And then the legs are the sides that are basically like attached or adjacent to, if you want to use the proper terms, adjacent, but I usually say it's attached to the right angle. So if this is my right angle, the two sides that the right angle connects to, which is this side right here and this side right here, those two sides are the legs. So this is leg and this is leg, and then again, these are usually called A and B. It doesn't really matter which one you call A or B, as long as you get that C is the hypotenuse, then you're good. Now again, this triangle can be flipped and twisted, so you might have a right triangle that looks like this. It's kind of like on its side. And again, in this case here, this side here would be my C, and then these two would be A and B. So always draw your arrow across the right angle if you're not sure, and that will usually point to your hypotenuse. Come on. So we use the Pythagorean theorem to solve when we have a missing side of the right triangle, and usually it can either be used to solve for a missing hypotenuse or for a missing leg. So for instance, in this case, we have a missing hypotenuse. So the way we set this up is identify what my A, B, and C are. So if this is my right angle right here, that means if I go directly across, that means that this is my C side, my hypotenuse, and these are my A and my B sides. Again, it doesn't really matter which one I call A or B. I can call either one of these A or B as long as I get that this side is C. So I'm going to set up my theorem here. A squared plus B squared equals C squared. We get 17 squared plus 7 squared equals x squared. I'll just do x squared. So all I'm doing is taking my variables and replacing them with either the number that goes with them or the variable that goes with them. So then I just go through this problem and solve for x squared, or x rather. So what's 17 squared? That's 289. So 289 is 17 squared. 7 squared is 49 plus x squared. Or sorry, equals x squared, not plus x squared. Draw a line down the middle here. And then I add these together. So 289 plus 49 gives me 338 is equal to x squared. Then I square root both sides. Again, the reason I'm square rooting is to get rid of the square. So square and square root cancel out, and I'm left with just x, which is what I want. It's like adding and subtracting, canceling each other out. And so then I square root 338. I get about 18 point, we'll say 4. 18.4. And that would be how long that side is. This side here would be 18.4 units long. And again, we can do like a little common sense check. And since 18.4 would be the longest side, 18.4 is bigger than either 7 or 17, then it would make sense to be the hypotenuse. If we got something like 16 here, then we know that we probably set this up backwards, because if we got 16, that means that it would be the second longest side. 17 would be the longest side, 16 would not be the longest side, and therefore it could not be the hypotenuse. So your hypotenuse number should always be the biggest number. So you can always check that as a reference after your problem to see if you're on the right track. The other problem, again, same sort of deal. We have a right angle right here. We know that if we draw my arrow across, this side is going to be my C side. This would be my A and my B side. So I'm going to start it out the same way. A squared, which is 22 squared, plus B squared, which I don't know, so I'm going to call x squared, because that's what x is equal to 25 squared. So once again, you square your numbers first. So I'm going to do 22 squared. So 22 squared and 25 squared. So 448 and 625. So 484 equals 625. And then I'm going to subtract this time to get x squared by itself. 4. That will give me x squared is equal to 625 minus 484, 141. And then I square root both sides to get rid of the square. So the square and the square root cancel out, and I'm left with just x, which is what I want. And then I do the square root of 141. And I get about 11.9, we'll say. Which again, makes sense because this side is smaller than my hypotenuse. So again, if I got like a 27 here, then I'd be worried that I probably set this up backwards because then this leg here would be longer than the hypotenuse, and that can't happen. So if you know your hypotenuse is 25, that means your answer can't be bigger than 25 because that's how long the side has to be, or that's the maximum the side could be in order to maintain it as a right triangle. It has to be less than 25. Not 25 exactly, but strictly less than 25. Now, we also had some of these where they were set up in word problems. And in word problems, the only real main difference is that you had to draw the picture yourself most of the time. So the distance between the base of a ladder to a wall that it leans against should be 1/4 the ladder's total length. What's the maximum distance up the wall that a 20-foot ladder will reach? Okay, so we have a lot of information going on here. Let's set up the diagram. So we're saying the base of a ladder to a wall. So let's draw this out here. So we have a ground here. Here's our wall. Here's our ladder. And then that's the base of it, obviously down here on the ground. So it says the distance from the base of the ladder to the wall, which is this distance right here, that distance should be at least 1/4 of the ladder's total length. So what is the maximum distance x up the wall? So distance up the wall, distance x up the wall. So that means that this distance right here is x, because that's the distance up the wall. A 20-foot ladder, so 20-foot ladder. So that would mean that this one right here is 20 feet. The ladder is 20 feet long. Will reach. Now, right now you might be saying, okay, well I know my right angle is right here. And the reason I know it's right that my right angle is right there is because that anything that's built on the ground, like a building or a wall, is assumed to be built at a right angle. That's just an assumption you can make in these problems. So my right angle is right there. If I draw an arrow across, I know that 20 feet is my hypotenuse essentially. So I'll call this my A, this leg here my A. The wall is basically acting as my leg A. I still don't know what the length of this line right here is. So this is the distance from the base of the ladder to the wall. I still don't know what that is there because it doesn't tell me the problem. But it does give me a hint. It says the distance from the base of the ladder to a wall should be at least 1/4 of the ladder's total length. So if this is the ladder's total length, which is 20, I'm going to take 1/4, 1/4 of 20, and I'm going to get 5. And that's going to be how long that distance is 5 feet. Okay. So the distance from the base of the ladder to the wall is 5 feet because it says up here that it should be at least 1/4. So we're going to take the at least part of it. We're going to take the lowest amount possible and say that's 1/4 the total length. So now we have everything set up in this triangle here. We have a leg side, we have another leg side, which is called 5 feet, and we have the ladder's total length. So we can set up an equation here. A squared plus b squared equals c squared. A squared is going to be x squared. B squared is going to be 5 squared. I should say plus there. 5 squared. And c squared is going to be 20 squared. So we do our little arithmetic here. So 5 squared is going to be, I keep putting equals. 5 squared is going to be 25. And that's going to be 400. Subtract 25, subtract 25. We get x squared is equal to 375. And square root, we get x is equal to 375 square rooted, which I should have done the other way. 375. We get about 19.4. So it's going to reach about 19.4 feet up the wall if you have a 20-foot ladder stationed 5 feet away from the base of the wall. So if the base of the ladder is 5 feet away from the base of the wall, it's going to reach up 19.4 feet up the wall. Now, obviously, if we made this longer, so if this was, 6 or 10 feet across, then it's going to reach up a smaller amount because you're adding more length on the bottom, which is going to cause the ladder to lean down a little bit and not go as much up the wall. So if I draw a picture of that here, if you have something like this, you're going to reach further up the wall than if you had something like this. So the farther you put the base out, the lower up the wall you reach. That's why we took the smallest amount here, because we want the maximum distance up the wall. So we want this distance from the base to the wall to be the smallest possible. But it has to be at least 5 feet because that's what it says here in terms of safety. It should be at least 5 feet. So that's why we took the at least part for sure there rather than just trying to estimate it from this range to this range. But again, the only difference with these word problems is you have to kind of draw the diagram to set it up yourself first. Once you get your triangle drawn, you're going to be given 2 out of the 3 sides. Use Pythagorean theorem to solve for the third. Just be aware of whether you're missing the hypotenuse or whether you're missing one of the legs there. Whoops. So lastly, we can use the Pythagorean theorem here to determine whether the triangle is acute, right, or obtuse. So obviously, this is the one we've been using here, that if a squared plus b squared is c squared, then the triangle is right. However, if this is not true, then we can have either one of 2 other options. If c squared is less than the sum, then we have that it's acute, which means it looks like this. It's like your standard typical everyday triangle. If c squared is bigger than the sum, then it's obtuse, which means that you have that slanted triangle, that leaned back triangle. And then again, if it's exactly equal to the sum, then it's a right triangle. So depending on how c squared fits, you can tell whether the triangle is acute, right, or obtuse just by checking the arithmetic. So for instance, let's see what these are here. So 9, 12, and 15. Are they acute, right, or obtuse triangle sides? Well, the thing you have to know here is, again, which one is my C? And again, C is always the longest side of a triangle, so in this case, C would be 15. 9 and 12 can either be A or B. It doesn't matter which one you call which. But as long as you get C identified first, then that's the main goal there. So 9 squared plus 12 squared equals 15 squared. Let's see if this is true. So we have 81 plus 144 is equal to 225. 81. So 81 plus 144 is indeed 225. So because they are indeed exactly equal, we know that this is going to be a right triangle. Because it follows the theorem exactly, the 2 sides are exactly equal to each other, we're all good. What about this one here, 3, 3, and 5? Okay, well the longest side here is 5, so that's my C. So I'm going to set up as 3 squared plus 3 squared is equal to 5 squared. So 3 squared and 3 squared are both 9. 5 squared is 25. We get 9 plus 9, which is 18, is equal to 25, which is definitely not true. 18 is not equal to 25. So this is definitely not a right triangle, but we do know that 18 is less than 25. So in this case, c squared, 18, is bigger than the sum of a squared and b squared. So if I took a squared and b squared and add them together, I got something that was less than what c squared is. So if c squared is bigger than the sum, that means we have it as an obtuse triangle. Okay, just let me go back for a minute. If c squared is bigger than the sum, then it's obtuse. And that's the case here. And you can probably guess what this next one is, but let's just go through it here. So in this case, 12 is my biggest side, so that's my C. Now, it won't always be the last side that's the biggest. That's typically how people write it, but this 12 can appear in any order in this list here. No matter when it appears, the biggest number is always your C. Whether it's the last, the first, or the middle number, the biggest number is always your C. So we have 11 squared plus 10 squared equals 12 squared. 11 squared is 121. 10 squared is 100. 12 squared is 144. This would be 221 is equal to 144, which is obviously not true, so it's not a right triangle. But we do know that 221 is bigger than 144. So we assess here. That means that c squared, 144, is less than the sum. Okay? So this is a squared plus b squared, 221. So c squared is less than the sum. And if c squared is less than the sum, that means it's acute. So we can use Pythagorean theorem not only to solve for right triangles, but to figure out if 3 sides would even make a right triangle or whether they would make something different, whether it be an obtuse or an acute triangle instead there. So again, it always depends on how C behaves. If C is exactly equal to it, it's a right triangle. If C is bigger than the sum, it's obtuse. If C is less than the sum, it's acute. And I should say C squared, not C. So if C squared is bigger than the sum, it's obtuse. If C squared is less than the sum, it's acute. So that's how you check to see what kind of triangle you're dealing with. So that's it for this video. Again, sort of a review for the most part because you've probably done right triangle stuff before. But again, if you have any questions, let me know. Otherwise, have a good day, night, or afternoon.